Oscillation discussion question 4. You were given a oscillating plate, and on this plate there was sand, and at this moment in time the oscillating plate was undergoing simple harmonic motion with a frequency of 13 Hz. The question asks you to sketch a graph to show the variation with displacement of the acceleration A of the plate. So what we know is that A equals to negative omega square x. In this case, omega equals to 2 pi f equals to 26 pi. So if I want to draw the graph, it will look like that. This is A. I'm going to put it as meters per second square, and this is x in terms of meters. So the largest amplitude that you can have is x naught and negative x naught. So we have here will be 26 pi square x naught and negative 26 pi square x naught, and the graph will look like that. It's a straight line graph passing through the origin and with all the points labeled correctly. Okay, part 2 actually asks you to calculate the angular frequency. So we have this just now, but I can't leave the answer like that. So I have to change it in terms of number of significant figures. So if you multiply this, you get 81.7, and the units will be radian per second. So this will be your part 2, number 1. Okay. The second one asks us to calculate the amplitude of oscillation such that maximum acceleration is numerically equals to acceleration of free fall. So A max equals to G, which is equals to 9.81 meters per second squared. So if I put in the values of omega, okay, I'm going to put in the exact value here so that it is actually more accurate. So omega square x naught equals to 9.81, and with this you get that x naught, the maximum will be 1.47 times 10 to the power minus 3 meters, which means that if this went up and down by 1.47 amplitude, the acceleration of this plate is actually 9.81. Okay. The last part asks us to suggest with a reason what happens if amplitude x naught is more than 1.47 times 10 to the power minus 3 m. So if you look at this value is closely related to A, because A max is equals to omega square x naught. So if this value is more than 1.47 times 10 to the power minus 3, it means that A max will be more than 9.81 meters per second squared. Okay, so what happens is that if I consider the part where I am at the top, okay, and this is the equilibrium point, and this is the bottom point, okay, and the distance between is actually x naught and x naught. So if I consider the part when I'm at the top, this is actually accelerating downwards with A max that is more than 9.81 meters per second. But you know that your sand here, its weight is actually accelerating down at 9.81 meters per second squared. So what happens is that the sand will actually be left above the plate. In fact, when the acceleration around in the middle is 9.81, the sand will already lose contact with the piston.